Hi, so I'm working on this project in ReasonML, and I have this function which returns a list of answers. For each one of these answers, it has to do a lot of computation, and the list itself could end up having an infinite number of answers in it, which could pose problems for lists. So I wanted to re-implement the function using a lazy sequence, like the seek module has in OCaml. Unfortunately, I'm using ReasonML, which has a lot of the same modules as OCaml, but it does not have the seek module. So I wanted to re-implement it myself in order to use it in this function. So I did it, and it was actually pretty interesting. There's a lot of like small little challenges. You can break it up pretty easily. And I just wanted to sort of share my solution and hopefully other people who are interested in OCaml, ReasonML, or just lazy sequences in general would find this interesting. So the goal is to re-implement this module or most of the module in ReasonML. All right, let's get started. Okay, so the first step is we're going to actually define the data type of this module, the sequence data type. So I'm going to do this by declaring a type. Oh, there it was. Type t, and this takes a parameter a, a type parameter a, and this is going to be equal to a node of type a, which we'll define in just a second. So in OCaml and ReasonML, generally if you have a data type that's being defined inside of a module, the module name, which is up here, the file name itself, is called the sort of the data type that you're naming. So in this case, seek. And then by convention, apparently you just use t, lowercase t, to represent the actual type that's defined inside the module. So to actually use this type, it'll look something like this. You know, seek.t, I could say like, let x be a seek of t of int, and this would be sort of like a list of integers, except a lazy list. Okay, so that's what that means. We're just going to refer to the data type that this exports as t. And then what's this node thing? Well, oh, actually this is wrong. So it's not just a node, it's actually a function which takes 0 parameters. So this is like a 0 size tuple of parameters, and it returns a node of a. So, okay, so what's a node? This is actually going to be a mutually recursive type definition. So a node of type A is going to be one of two variants. So the first variant is called nil, and that sort of represents an empty sequence or the end of a sequence. And the other variant is called cons, and this has two things inside of it. So it has an A, and then it has a T of A. Okay. This should be unit, since it's in the type level. Okay, so unit is the empty tuple. All right, so what this actually means is it's very similar to just a regular list, which might be written as something like let my list of tick A equal nil1, or cons of a tick A and a list, my list of tick A. So that's sort of how a regular list looks. The only difference here is that instead of referring directly to the recursively referring to the type itself here, we just have a function that returns another one of these. So these, it'd be kind of nice if we could phrase this as like, in our lazy list example, if this could just be a function from here to here. It turns out OCaml's type system doesn't really like that, so you sort of have to break it into two pieces. But that's fine. Okay, so that's sort of how it's defined, and then this would be sort of like an example of an element of this type. So it would be a sequence of t. Actually, since we're inside the module, I can just say t, and let's say it's a t of int. And then to actually define this, I would say something like, okay, first element is 1, and then the second, in the second place here, I'm going to have a function which returns another cons, and this could be 2, And the second element here is a function which returns another cons, which has the element 3. And then finally, we return nil. So, all right. And I'm getting a type error because this whole thing actually needs to be a function. So the interesting thing about sequences is if you just are given a sequence, this T of type A, then you know that it is a function. It just happens to return this weird data structure when you call it. So this is an example, and this is analogous to just the list 1, 2, 3. Okay, so that's sort of how the data structure looks. The first function that I want to define here is actually not a function. It's just going to be called empty, and it's sort of an associated value, or a value associated with this module. And this will just give us an empty sequence containing no elements. Okay, so in ReasonML, I'm going to say empty is a T with tick A. Okay, so that's its type, and it's going to be equal to a function which just returns nil. Okay, so that's pretty simple. If I just want an empty thing instead of, if I was using lists previously and I had an empty list, I'm just going to transform that into empty, and that'll be sort of equivalent. Okay, the next function that we're going to define is return, and this it's a singleton sequence containing only the given element. So the way that's going to look is we'll do return, which takes some value of tick A and just transforms it into a T of tick A. Okay, so this is going to be a function which takes, maybe we'll call it x, and then it just returns cons of x and empty. I think that'll work. Oh, it needs to return a function. Okay, so let's break this out a little bit. Right, okay, I'm constantly forgetting that a T of A is a function. So if I'm returning a T of A, I actually need to return a function. All right, so that's the first two elements of this module done. And the way I might use this return function is I could say let my thing equal return 1, and that's just sort of a shorthand for returning a singleton element. Okay,